divided by 100 into 100, we have 10% W by W. It means 10% W by W of sodium chloride in water. It means when 10 gram of sodium chloride is dissolved in 90 gram of water, then it forms 10% W by W of solution. We will discuss volume percentage. Next one. That is percentage P by V. It is defined as volume percentage of a component percentage P by V is equals to volume of component divided by the volume of solution multiplied by 100. This is percentage, volume percentage, that is percentage P by V, which means volume of the component divided by volume of the solution multiplied by 100. If we have a question that what we mean by 20% V by V of ethanol in water, then this means 20% V by V of ethanol in water. It means when 20 ml of ethanol is dissolved in 80 ml of water, then it is termed as 20% V by V. Let us see. Percentage V by V of ethanol in water. It is equals to, what is, we have the volume of ethanol, that is 20 ml. What is the volume of the solution? That means volume of the solute plus volume of the solute. Volume of the solute is 20 ml. Volume of the ethanol is 80 ml multiplied by 100. It means we have 20 by 100 into 100. That is equals to 20% V by V. What we have? We have 20% V by V of ethanol in water. Water means a solution which is formed by dissolving 20 ml of ethanol in 80 ml of water, then its concentration is 20% V by V. To the next we will discuss the mass by volume percentage. It is mostly used in pharmaceutical industries and it can be represented as the amount of solute in 100 ml of solution. What we have? You have the next one, third one, mass by volume percentage. That is V by, that is W by V percentage. It is defined as the amount of solute solute in gram dissolve in 100 ml of solution. It is mostly used in pharmaceutical industry. Mass by volume percentage, it means the amount of solute dissolved in 100 ml of solution. It is termed as mass by volume percentage. To the next, we will discuss parts per million. Parts per million. It is abbreviated as ppm. It is used for trace quantity. It means when the solute in a solution is in trace amount, then it is represented by parts per million. So first one, it is used to represent the amount of solute which is in trace amount in a solution. It means the solute is in trace amount, then we are going to represent it by parts per million. It means ppm, it is equals to the number of parts of a particular component, the number of parts of a particular component divided by total number of parts of all components. Total number of parts of all the components into 10 to the power 6. Parts per million, it can be represented as of a component is equals to the number of parts of a particular component divided by total number of parts of all the components multiplied by 10 to the power 6. This is how we are going to represent the parts per million. Parts per million can also be expressed in the form of W by W or V by V. W by W, it means if we are taking the number of parts of a particular component, if we are taking it as in the form of mass, then we will take the total number of parts of all the components in terms of mass. Then it is termed as what? W by W. If we take the volume of the components, that is of the solution and the solute, then it is termed as V by V. It means the ppm, it can be represented in the form of V by V or W by W. In both forms, we can represent the parts per million. Let us take an example. If we have an example that the seawater contain dissolved oxygen in that. If we have 1 liter of seawater which weighs 1030 gram, which contain 6 into 10 to the power minus 3 gram of dissolved oxygen, then how we are going to represent it in the form of parts per million? What is the question? A liter of seawater weighs 1030 gram, which contains which contains what? 6 into 10 to the power minus 3 gram of dissolved oxygen. Then how we will represent this in the form of parts per million? It can be represented in the form of percentage ppm W by W. How? It means ppm of oxygen in water. That is equals to what we have? 6 into 10 to the power minus 3 by 1030 gram. 1030 gram, it means 1030 plus 6 into 10 to the power minus 3. Total number of component in the solution into 10 to the power minus 6, which is equals to 5.8 ppm. When you solve it, then you will get 5.8 ppm. It means 5.8 gram in 1 million grams of what solution. We will discuss the new way of expression, that is mole fraction. Mole fraction, it is defined as the number of moles of a particular component divided by total number of moles in the solution. What is that one? That is mole fraction. It is defined as the number of moles of a particular component divided by total number of moles in the solution. It is represented by X. Let us see how it is going to represent. If we are discussing X, that is the mole fraction of a component, then it is equals to, we will write mole fraction of a component. Mole fraction of a component, it is equals to number of moles of a particular component divided by total number of moles in a solution. It means it can also be represented as, if we have a number of component in the solution, then in that case mole fraction is represented as XA is represented as NA divided by NA plus NB plus NC plus N. It means the mole fraction, where Na is the mole fraction of A, Na plus Nb plus Nc. It means these are the mole fraction of different component in the solution, and when we add up, then we will get the total number of moles of all the component in the solution. This is how we can calculate, we know the mole fraction of a particular component. It can also be represented as, if you are writing 1, then we'll write x1 equals to n1, 1, 2, 3 and infinite. x1 it is also represented as n1 by summation of what? Ni, where I varies from I equals to 1 to n. This is the expression of the mole fraction of a component which contains more than one component. For binary mixtures, it means it contains two components. Let us suppose one component to be A and the other component be B. In that case, for binary mixtures, the mole fraction XA is represented of number of moles of A divided by total number of moles in solution. It is also represented as XA equals to NA by NA plus NB. This is how we are going to represent the mole fraction of A. If we want to represent the mole fraction of B, then it can be represented as NB by NA plus NB. In order to calculate the moles, which is represented as N, it is equals to weight of a component divided by molecular mass. It means N number of moles is equals to W by capital M. To the next, if we have two component, then in that case, if we have two component, then when we add up the mole fraction of this two component, we will got 1. It means when we add up XA plus XB, it is equals to 1. If we have a various component in the solution, then in that case, if we add x1 plus mole fraction, this one x1, in the same way x2 plus x3 plus and so on, plus xn, it is equals to 1. It means the mole fraction, if we add up the mole fraction of different component in the solution, then it is equals to 1. If we have two component and if we have got the mole fraction of one component, then by subtracting, if we want to get XA, it means XA equals to 1 minus XB. This is all about the mole fraction what we have studied. Let us discuss what is molarity and what is molarity. Molarity means the number of moles of solute in a liter of solution. And molality means the number of moles of solute in 1 kg of solvent. This is the difference between the molarity and molality. Let us discuss. The first one is molarity. Molarity. It is represented by capital M. It is represented by capital M. The next one, we know molarity. It is defined as the number of moles of solute in. It is defined as the number of moles of solute in 1 liter, or the volume of solution in liters. In volume of solution in meter. Molarity it is represented as capital M. It is equals to number of moles of solute divided by volume of solution in meter. What we see here, we have volume, then it means the molarity is affected by the change in temperature. It means molarity is affected by change in temperature. What it means, if we increase the temperature, on increasing temperature, the volume increases. When the volume increases, then the molarity decreases. We know the number of moles of solute. The number of moles of solute, it is N. N is equals to what? W by M. W is the mass of solute and M is molecular mass of solute. It can be also represented as M is equals to what? We will write W by M by V in ml divided by 1000 ml. It is equals to W by M into V in ml into 1000. This is all about the molarity. So the next we will discuss the molarity. Molarity, it is represented by small m. It is defined as the number of moles of solute in per kg of solvent or in amount of solvent in kg. And molarity, it is equals to